Hey everyone, welcome to The Explainer. Look, I know you've been grinding away, right? You've been studying night after night, trying to break into or level up in the data world. But we really need to have a fast, hard reality check today. We're looking at the 2026 Data Engineering Roadmap, and honestly, I have to tell you, your hard work might be pointed in the exact wrong direction.
Most people learning data engineering right now are wasting their time. Okay, just let that hang for a second. I know it sounds super harsh, but listen, it is not because you aren't working hard. The effort is absolutely there. The problem is just that you're learning the wrong things. You're basically preparing for a version of the industry that simply doesn't exist anymore, focusing on these outdated priorities while the real job market has completely moved on.
Okay, let's dive into this. We are going to fix your approach right now with a completely structured, no-nonsense plan. Today's explainer covers 4 quick parts. First up, the reality check. Second, a phase-by-phase learning roadmap. Third, the actual projects that get you hired. And finally, winning the job strategy.
All right, Section 1, the reality check. Let's reset the industry hype.
You see, data engineering today is no longer just this back-office job of moving data from point A to point B. It has fundamentally evolved. It's the vital engine that actually makes modern AI possible. If we look at what companies are really hiring for right now, modern systems must be reliable, real-time, cost-efficient, and fully ready for AI. Now look, batch processing isn't dead by any means, but it's just no longer enough on its own. Real-time is rapidly becoming the new default. Because think about it from a business perspective for a second. If your data is slow, your decisions are late. It is literally that simple. You have to build systems that handle events exactly as they happen.
So the crucial point is that AI didn't replace data engineers, it actually made them exponentially more important. Bad data doesn't just break a couple of internal company dashboards anymore. Now it creates confidently wrong AI. And let me tell you, confidently wrong AI is incredibly dangerous. If you are the one responsible for feeding context to large language models through pipelines and embeddings, that data has to be flawless. Otherwise, the AI is going to hallucinate with absolute certainty.
And this brings us to a massive mindset shift. Think about the beginner mindset. It's basically collecting tools like Kafka, Spark, and Airflow like their merit badges. You got to stop doing that. The actual engineering reality is that you need to start building systems. Companies do not hire tools. They hire problem solvers who can design robust systems, debug massive failures, and actively reduce compute costs. Honestly, deep knowledge of Core SQL and Python alone can still get you into the industry, but only if you truly understand them deeply enough to solve complex, real-world problems.
Let's move on and see how this builds in Section 2, our phase-by-phase learning roadmap. And spoiler alert, there are absolutely no shortcuts.
All right, this is where the methodical, slow-paced work begins. Grab a notebook, because here is your timeline over the next 9 solid months of effort. Month 1 is entirely dedicated to foundations. Months 2 through 4 focus on core engineering. Months 4 through 6 pivot over to cloud and scale. And finally, months 6 through 9 are all about those high-value skills. I really want you to keep this concrete visual anchor in your mind for the journey ahead. If you try to skip ahead to the flashy stuff, I promise you, your foundation will eventually crack under pressure.
Let's methodically break down these first 2 critical phases. Phase 1 is foundations. Honestly, this is where most people hit a wall. We are talking real Python scripting here, not just following easy copy-paste tutorials. We mean deep SQL, like truly understanding joins, window functions, and query optimization. And you absolutely need data modeling. Listen, if this first phase is weak, your ability to turn messy data into clean data sets in Phase 2 completely collapses. Now, Phase 2 is core engineering. This is where you reliably clean that messy data using tools like dbt for transformations, Spark for scale, and Airflow for orchestration. But again, none of those tools matter even a little bit if your foundational SQL is shaky.
Which brings us to Phase 3, cloud and scale. And that stark number you're looking at is the most important piece of tough love I can give you today. 1. Pick exactly 1 cloud provider to learn deeply. Please, not 3, just 1. Go incredibly deep on their storage mechanisms, their compute engines, their permission structures, and how to actually manage their costs. Learn Terraform to deploy it all. This is the stage where you have to understand exactly why systems fail when they try to scale up.
Finally, Phase 4, taking us through months 6 to 9. This is where you officially separate yourself from the beginners. You must master high-value skills, and right now, today, that means AI-ready systems. These are the infrastructures that supply clean context to LLMs through embeddings and vector search. which basically translates raw data into numbers that AI can actually understand. But hey, it's not just about AI. At this level, you also need to master real-time streaming with tools like Flink or Kafka, strict data quality, because if users don't trust your data, you are basically irrelevant, and aggressive cost awareness. Remember, a pipeline that works perfectly but wastes thousands of dollars a month is a bad pipeline.
Moving to Section 3, Good Projects. It's time to really start thinking like an engineer.
Look, just having random projects on your resume isn't going to save you. Only having good projects that accurately mimic real-world engineering environments will actually get you the interview. Let me save you literally months of confusion about what hiring managers want to see. You don't need 10 generic tutorial clones. You just need exactly these 3 projects. First, a batch pipeline showing a full end-to-end ELT process, extract, load, and transform. Second, a real-time pipeline that demonstrates a working streaming system. And third, a comprehensive Lakehouse project. If you build these 3 specific things, you absolutely prove you can handle modern, multifaceted data challenges.
And this brilliantly illustrates how a comprehensive Lakehouse project follows a standard architectural progression. Step 1 is bronze, which is just ingesting the raw data. Then moving to step 2, silver, representing your cleaned, filtered, and transformed data. And finally, step 3, gold, which is the heavily refined, business-ready data that actually drives company decisions. Showing this full progression proves to a hiring manager that you deeply understand data lifecycles and governance.
But here's a critical gut check question you have to confront when looking at your own portfolio. Are you building like a student or an engineer? See, most people fail at the interview stage because they build like students. They run a script locally on their laptop, it finishes without throwing an error, and they just call it a day. They completely lack performance metrics, they never actually deploy the code to a cloud environment, and they provide zero explanation of why the pipeline actually matters to a real business.
To fix this, you have to treat your projects like actual production systems that break, that need to scale, and that cost real money. In your project write-ups, you need to explicitly show 3 things. Latency, exactly how fast does it run? Cost, how much would this infrastructure cost per month in the real world? And architecture, provide a clear, professional diagram of how all the components interact.
All right, let's speed things up for Section 4, winning the job strategy. When you have the right skills, hiring gets a lot simpler.
This is where we translate all those hard technical skills into a winning strategy. And here's the ultimate resume rule. If you didn't measure it, it didn't happen. Look at the bad approach. I built a pipeline. Okay? That tells a hiring manager absolutely nothing about your impact. Now look at the good approach. Reduced processing time from 2 hours to 10 minutes. See the difference? That tells them you understand business value, optimization, and real-world results. You have to quantify everything.
When you finally step into those entry-level interviews, here's what to expect. Your technical baseline is going to be heavily tested on strong SQL and Python. Do not gloss over those. Next, your understanding of architecture will be tested through system design questions. But pay close attention to that last point. The absolute deal breaker is communication. Technical skills might get you into the room, but your ability to clearly communicate is what actually gets you the job offer.
Now, what's really interesting about this is that it exposes the biggest trap in tech. If you can't explain your system, you don't understand it. Clear communication isn't just some fluffy soft skill to brush off. It is the ultimate proof of engineering competence. If you've built an incredible, cost-efficient pipeline, but you can't articulate exactly why you designed it that way to a hiring manager, there is no way they're going to trust you to build systems for their company. Which brings us to our final thought for today. Without good data systems, AI is just expensive guessing. In 2026, data engineers are not optional. You are literally the foundation of the AI revolution. So please, stop chasing every new trendy tool that pops up on your feed. Go back to the basics. Start with SQL. Build real systems. Break them. Fix them. Because that is how you become incredibly valuable in this industry. So, looking at your own learning journey today, are you preparing to just move data around like a student, or are you preparing to architect the systems that will run the future?